Good morning, students. Today we will learn how to plot graphs. Now, whenever we are asked to represent any tabulated data in a pictorial form, then the best way to do so is to draw graphs. Graphs are nothing but pictorial representation of data. Prior to this, you have drawn different types of graphs in mathematics. In your junior classes, you have learnt about tabulation of data, tally marks. Remember? So, in that portion, you have studied about bar graphs, pie graphs, pictographs, and perhaps also you have learnt how to plot line graphs. In the syllabus of physics, we need to study only about line graphs, like representing the variation of one quantity with respect to the other on a piece of graph paper. That's exactly what we will be learning today. I will tell you how to plot two quantities, one quantity which is dependent on the other, and the variation of one quantity with respect to the other that will be plotted on the graph paper. For this, I will be considering a very simple condition, and using that condition, using that equation, I will be drawing the graph paper. I will be drawing the graph on the graph paper. Okay, so let's begin. So as you can see, a graph paper is coming on the screen. You can very well see the grids. On a graph paper, you are having bold lines marked at regular intervals, isn't it? You are having bold lines on the vertical side as well as on the horizontal side. Now we are always plotting points on these bold lines, but let me zoom it a little bit so that the grids are properly visible to you. You can see small boxes. Can you see them? In between the bold lines, you are having many small boxes. Like between two consecutive bold lines, how many small boxes are present? If you count them, there are 10 small boxes. If you are moving from one line to another, one bold line to another, either in the horizontal side or on the vertical side, on either side you are having 10 small boxes. Now I will be telling you how to plot points on these bold lines and then how to find out the value corresponding to every small box. But that will be done a bit later. Prior to that, the first thing that we need to do on this graph page is to draw the axes. Okay. So we will require two axes, the x-axis and the y-axis. The vertical line is called the y-axis and the horizontal line is called the x-axis. These two axes intersect at a point called origin, that is O. Okay. So now we will consider a very simple equation, y equals 5x. With change in x, y will vary. So as y changes with respect to x, so y is the dependent quantity and x is the independent quantity. So let us find out the values of y with respect to x. Y equal to 5x. Now I have already solved for y corresponding to three different values of x. See, y equal to 5x. For x equal to 1, I have solved y equal to 5 into 1 equals 5. You can see accordingly I have written x1 and y as 5. Similarly, for x equal to 2, y is 5 into 2 equals 10. And I have written x2, y as 10. For x equal to 3, y is 5 into 3 equals 15. So x is 3, y is 15. Let's solve for the next value. So for x equals 4, y equals 5 into 4, that is equal to 20. So I have written x equals 4 and y equals 20. Now similarly, very easily we can write down for x equal 5, y is 5 into 5 25, x equals 6, y is 6 into 5 30, x is 7, y is 7 into 5 35, x is 8, y is 8 into 5 40, x is 9, y is 9 into 5 45, and x is 10, y is 10 into 5 50. So these are the 10 values corresponding to x and y that we'll be plotting on the graph paper. So let's begin. Now let's start plotting on the x-axis first of all. So corresponding to the values that we have plotted for x, we will start marking one by one on the bold lines. See, as I told you that I will be plotting on the bold lines. So one thing that you should remember, that the spacing between every consecutive value should be same. Like see over here, 0, then 1, then 2, then 3. The spacings are equal. Similarly, we will start plotting on the y-axis. 5, 10, 15, 20, 25, 30, and so on. Now I don't need to follow a spacing of 1 on the y-axis because the values for y are in multiples of 5. So in total we are having 10 values of y and 10 values of x. So very quickly I will write down on the x-axis side, these are the x values, and on the y-axis side, y values. The arrow actually represents that is in this direction the values are increasing. Okay. Now y equal 5x. So as y is the dependent quantity, so it is always plotted on the y-axis. And x is the independent quantity, so it is always plotted on the x-axis. So you should remember this, that the dependent quantity should be always on the y side and the independent quantity should be always on the x side. Okay. So before we start plotting, we need to find out the value for every small box. So first of all, we will find out for x-axis. Let's see what is the value for one box. Value of one small box. So 10 boxes equals 1. From 0 to 1, the spacing is of 1. So 10 boxes equals 1. So therefore, 1 box, simple unitary method, it will be 1 upon 10, and that is equal to how much? 0.1. Clear? So every single box is having a value of 0.1. Understood? And now in the same manner we can do for the y side. So again, for y axis, value of one small box, this will be 10 boxes equal to how much? 0 to 5. So the gap is of how much? It is of 5. We are moving through 5 steps. So 10 boxes equals 5. Therefore, one box will be equal to 5 upon 10. That will be equal to how much? 0.5. So this means for x-axis the value is 1 box equal to 0.1, and for y-axis 1 box is equal to 0.5. Okay, so now let's start plotting on both the sides. Considering the values on both the axes, let's start plotting. Now for your convenience, I will be putting the values on one side so that the values are visible once we start plotting on the graph paper. These are the values that we have to plot on the graph paper. So let's keep it like this so that the values are visible to you all. Okay, now let's start plotting. So for x equal to 1, y is equal to 5. X equal to 1, y is 5. So x is 1 and y is 5. So this should be the point. Okay, corresponding to x equal to 1, y is 5. Next, for x equal to 2, y is 10. So let's start plotting. X equal to 2, y is 10. This will be the point. Similarly, x equal to 3, y is 15. So see, x equal to 3, y is 15. That is the point. So in this manner, we can find out the different points accordingly. Say x equal to 4, y is 20. So this will be the point, and accordingly we can proceed. So similarly, we will plot the remaining values. Okay, we will plot all the values similarly. So we will be getting the points like this. Okay, so now you can see for 5 it is 25, for 6 it is 30, 7 is 35, 8 is 40, 9 it is 45, and for 10 it is 50. Now let's finish what we were doing for every single point. Very quickly we will do it. Okay, mark all the points so that you can very conveniently see that what is the corresponding value of y for a given value of x. That's why I'm marking these dotted lines. Now usually when we are drawing a graph, it is not necessary to always point out like this, but when you are learning how to plot points for the first time, it becomes convenient to understand if we are marking like this, so that you can tally, so that you can understand that no, we have not made any mistake while plotting the values. Okay, normally once we have practiced learning how to draw graphs, we don't really mark these dotted lines. Now for the sake of convenience, I have marked the points like this. Okay, so now we need to join all these points. For that we require one scale. Now any drawing like this, a line graph, needs to be drawn. If it is particularly a straight line, you need to use a scale. Okay, so with the help of scale you can join all the points, since all the points are coming on one line, and in this case the line will be passing through the origin. isn't it? So I will be joining all the points and see what type of a graph we can obtain. Okay, so let's join all the points using these values. Using these points, let's join it. So I will be started joining all the points and see it is coming a straight line. So for this particular equation, y equal to 5x, you are getting a straight line passing through the origin. I am just encircling the points so they are properly visible to you. See, okay, so this is how the graph will look like. Now whatever we learnt about graphs, that we will be revisiting once again. I am simply tallying the values. You can see these were the values and this is how the graph is looking like. Okay, understood? I think it is pretty much clear to y'all as to how we can plot the values on a graph paper. Now let's quickly recapitulate what we learned. Okay, so y equal to 5x, y is a function of x. What does that mean? As x changes, y also changes. Okay, as x changes, y is also changing. So x is an independent quantity. It is independent, isn't it? And y is a dependent quantity. Dependent quantity is always plotted on the which axis? Dependent quantity is always plotted on the y axis. Dependent quantity will always be plotted on the y axis, and independent quantity is always plotted on the x axis. Okay, dependent quantity on the y axis and independent quantity on the x axis. So these are the things that you need to remember while drawing any graph. I guess now you will be able to draw any graph easily, isn't it? So using this content, you will be trying to draw one graph. So for today, I am assigning you one homework. Draw a graph for y equal to 2x plus 2. Okay, so this will be your homework for today. We will end our session at this point. Thank you.